Hi, everyone. It's Sam and Jessie from ING office. I'm from the WBA Advanced Analytics team, and Jessie is from
ING Analytics. So welcome this afternoon, or at least in our time zone, welcome this afternoon for the second online data engineering meetup. We are very excited. Can you please confirm that you hear us, so that you are sure in terms of technology? So we have three amazing speakers this afternoon.
Yes.
Even one all the way from Singapore. So for him, it's now very late in the evening. So we're very happy that he will join us. So everyone hears us loud and clear. So let's start.
Let's start, and let's give the podium to Prince Kerr, our chapter lead from the Singapore office. First time is joining us on this online event meetup, and we're very proud. So good luck, Prince.
So let's start with his first talk of this data engineering meetup.
Guys, can you hear me? Yeah. Okay. Yeah, guys. This side Prince. I work as a chapter lead in ING Bank. For we do data analytics. We head the data analytics and the regular reporting for Asia branches. We have around about 9 branches, and we do extensive use of these technologies from a MSBI stack to a Power BI. So I've been experienced in Power BI for so long. I think almost 7 years. So that's my personal so-called profile. So let's start. So what I'm going to discuss today is mostly about the Power BI and the way we can use Power BI for our so-called ad hoc reporting. As we all know, we know data engineering stuff, that we know how to get the data and all this stuff. The issue is that what people say is that 90% of work is done in the back end. Only 10% shows up, but actually the showing of the reporting, the analytics part, the front end is the major part. That if you cannot present what is back in the back end, it doesn't help people make good decisions. This is where we come up with these so-called as Power BI architecture. So the so-called Power BI ad hoc reporting tool that can help you with a very fast and a very good decision making report dashboards on it. So let's get started with the architecture. Okay, so what is this Power BI architecture? Power BI is part of a MSBI suite, Microsoft suite, where it helps you do a lot of reporting stuff, starting with so you can define Power BI into 3-tier architecture. The first kind is the data sources. You can have n number of data sources across. As you know, Microsoft allows a lot of data sources to be attached to the Power BI as well. Then you have a Power BI desktop. That is a layer where you develop your reports. You can see what you're doing it with the data. You can see what is there. And then it comes to cloud services of Power BI. That is more of your how you display your reports, how you publish your reports, which all people can see and all that stuff. Then as we know, the data is being a very sensitive information across the whole organization. Power BI gives you gateways to interact with data, because sometimes people don't let your data go onto clouds and all those services. So where Microsoft steps in and tells it, okay, fine, guys, you can have your data in your systems, in your sources. We won't publish it on our cloud service, but you can still use our cloud services to show the dashboards and all the stuff. And then comes how you access the reports, the real stuff. Okay, it tells you where you can have it on your mobile reports. You can have your CEO can see the so-called your KPIs very fast, in a very, very fast-paced manner on the so-called mobiles and all that stuff. And so this is in short is a small architecture of the whole Power BI. Let me see. Okay, sorry. Yeah. So how do we divide this so-called analytics solution? Analytics solution has certain parts and components to it. One is first is your so-called data layer, where your extraction happens of the real data. And in composite, Power BI gives you Power Query editor to do those things for yourself. Then you have a data modeling. Power BI has its data models also. Then it comes the data storage. Power BI has a very good engine in terms of the data storage. That is a DAX storage engine which uses a tabular model. It's a vertex. It summarize it. It so much comprises your data in such a zip in so much zip that you can have tons of data without any performance issues as of today. Okay, then comes the data retrieval. How do you retrieve the data? You have SQLs and those things. In Power BI, you have a DAX query and M queries that we will discuss later on the slides also. Then analysis tool. You have a very good analyzing tool in terms of Power BI also. You can have your Python and R also integrated with Power BI, and you have a lot of visualizations to view those stuff, and can predict a good story, can project a good story out of the whole report. The presentation itself is you have visualizations. That's something we will cover later on the slides also. Then comes, how does this Power BI working architecture happens? Okay, you you have two halves of the Power BI architectures. One is your upper half, that is more of your cloud services that it gives you. Then the lower half is where your data resides into systems. Sometimes people don't even use the upper half, they all uses the mainly the lower half, where they have the report server also published within their systems, where they don't even go outside of anything. So it depends upon what kind of stuff you want to do with the Power BI, and the way your data, so-called your data integration, your so-called integrity of your data, so-called confidentiality, which one you want to share on the cloud services, which you don't want to share. That is something you can decide on the way it goes across. Today, the basic topic what we want to discuss is how Power BI is useful in doing a lot of analysis. So we will show you why Power BI is ad hoc why Power BI is what are the use cases for the Power BI being a why do we should we use Power BI for ad hoc reporting. One, Excel is quite an old tool now. Excel doesn't allow integration with a lot of data sources. Others cannot do it. And then it has a you can in Power BI you can connect your data warehouses, you can combine various data sources together. DAX query, being from a business user perspective, is a very easy language, but it's a complex but still an easy language if you do a lot of small analysis and all the stuff. So these are the stuff that you can, why we prefer Power BI to be used across with users. How do you create a report? So it tells you a clear steps. How do you create a Power BI report? How the data integration happens. First is how where your you have to integrate your data into the system in the application. So this is where your data integration happens. Then you have a lot of transformation. People say people don't get a lot of transformation from Power BI, but I can tell you there is not a single task that I can do it in SSIS that I cannot do it in Power BI from regarding a transformation. So there are ways out of it to do things. There are stuff that you can do it across. So these are the different things you can a lot of transformation that we will see also in the later slides here. People say you can do data modeling. Same data modeling can be done in Power BI as well. You can see I have put a small screenshot of a very small facts and dimensions across. So this is a very small data model, but you can create a big data models as well. um, then you go and define what is your driving, then you define and drive your KPIs, how you want to drive this data out of it. That is something in the later slides. Then the last part is how you put your report and publish the dashboards. Comes the next one. It gives you a very small slide to show how does this Power BI desktop looks like, and where are the stuff from the each gives you how you import data, how you format, how you enrich data, how you set relationships, build your report template, and all this stuff. So this is how the whole simple steps of Power BI, how to create simple reports. Okay, now let's jump into the real stuff of data analysis. Okay, so we'll start with how does Power BI do a forecasting. You can do a forecasting in Power BI. A user that doesn't understand so-called algorithms and all this still can do a Power BI forecasting. It's very simple steps. I'll tell you what does Power BI uses as a forecasting model. It uses an exponential smoothing model. Uh, it uses two techniques. It's called as ETS AAA and ETS AAAN models. What does ETS stands for? It's an error, transform, uh, uh, error, trend, uh, and the seasonality. Okay, so what does this error, trend, and seasonality means to? Okay, so you see there are some businesses where you have a lot of seasonal data. For example, winter's clothing will be will be much of higher use, much of higher profitability in so-called winter season, as compared to in summer season. So that's something called a seasonality. Maybe it can be quarterly seasonality also. It all depends what kind of seasonality you have it. Okay. So ETS, how does ETS work? So ETS, if you see this models under ETS AAA and AAN, what it predicts that ETS AA, what is AAA and what is AAN means to it. Okay, so error term, what is an error term? It can be additive and a multiplicative. I'll show you later on the formulas across it. Okay, how does it work? So same for the trend term also. It can be additive. It can be of a so-called multiplicative. Even it can be of no trend. It can be a very straight line, streamline. There might be a very flat line that doesn't show any trend across the time series. So and then seasonality comes. Seasonality is one of the major factors to determine which model out of this ETS it will use. So basically what we are going to do, we are going to start with ETS AAN model. So what it tells you, it's actually equivalent to Hall's linear model that we have it. Okay. So you will only can use this model because if you remember, I told you ETS XYZ, if you convert it to AAN, it tells you it has a error term that can be additive. It should have a trend that is additive. See, it cannot have a seasonality data. So if you don't have a seasonality data, then it tends to use this model to do the forecasting prediction. Okay. It's equivalent to a REMA model that you will see, that auto regressive integrated moving average model. So it follows the same stuff here also. So if you see, I'll give you just an example. It gives you a Google stock. Google stock doesn't have any seasonal impact to the data about the stock prices, because Google is just Google. It doesn't matter whether it's quarterly, whether it's month one or month two, or time period one or time period two, is still the same. So it doesn't have seasonal data. When you don't have a seasonal data, then it tends to forecast with a very straight line. Okay. Then comes the ETS AAA model. It's equivalent to a triple exponential smoothing model also. So if you see, for example, the milk production might go up and down due to the seasonal, with respect to dairy farms stuff. Correct. So that's how it works for the seasonal data. Then so you will see sometime peak, sometime very lows. So that's how it works. Let's get into okay. Now we being in a COVID situation, so I thought this would be a better example to showcase. Okay, if you see this, it is following a AAN model because it doesn't show any seasonality data. Okay, so if you see this data across, what I have done, okay, I have forecasted from the data from January till May 26th or 27th, something like that. So I had that data from the internet, and then we just put it as an active cases per day. On that day, what is the end number of active cases on that day? So if you see the whole forecasting done by Power BI, let me go to the real data. Give me a second. Yeah. Okay. So now we are on the Power BI report itself. So if you see, you can see this orange line. This orange line depicts the forecasting. So what I did to check my forecasting, whether it works fine or not, what I did, I ignored 6 months. I ignored almost a month of data to see whether where what is being forecasted is actually on the same lines what is being the actual values. Okay. So if you see this, so you can see the upper bound and the lower bound. It tells you about the how much confidence level we have it. So right now I've put it as a confidence level as 95%, so interval, so that at least to make sure that the data stays in this. Because of COVID-19, there are a lot of peaks and a lot of drops. So that is the reason I haven't practiced this. I haven't made this machine learning too many stuff, so that I don't have too much of confidence level. So I've put a bigger confidence interval out there. So how does this works? So I'll just give you an example. Okay. I'll change this forecasting. Okay. I'll change this forecasting confidence interval to 75%. You will see the impact. Okay. see it got decreased, but still if you see our forecast lines and the real actual lines are actually almost similar. So it when I calculate the percentage of change that is there in between, we call it as RMC, MAP matrices. It shows MAP percentage matrix shows me around about 8% deviation, and I think that is a very good forecasting in that sense. So that so we can see Power BI is actually able to forecast very closer to the accurate values, to be honest, as long as this values so I'll explain in next slides what are these values towards MPSC and all those. Okay, give me a second. So I just showed you that forecast length and how does it works. So what it tells you, it can Power BI gives you a so-called uh, sorry Power BI gives you so many variables that you can play around with. For example, you can play around with what kind of how many months of data you want to see, how many months of forecasting you want to see, or how many years or how many time periods you want to see. And you can always test your model by ignoring certain months. So either you can ignore your months as per your need basis. For example, there are some outliers that you don't want to put into the system, so you can remove those by using this ignore months. But if you have certain but even for testing also, you can use this ignore months, so that at least you can see whether your prediction levels are going properly or not. uh, and this confidence interval level, we have already discussed what is this confidence interval is all about. So so there are two very good accuracy method that you can always use to see whether it's there or not. So one is RMC, that is root mean square error. So if you go ahead and check your actual whatever you okay, let me show you one more thing. uh, it does not only tell you the values, you can see the values also. Okay, so you're just seeing this here, you just right click. Okay, show as table. If you show it as table, it tells you, okay, initially there is no forecasting because I asked it to focus from May month. Give me a second, guys. Okay, so if you see, you have a forecasted value from 26th because I said started ignoring 1 month from 26th May, so it started forecasting from this value. So if you can see, it's a very close values when you see it around. So that way, you can see your forecasting model is very nearby, and you can use these value to derive this formula. Uh, the percentage, the map percentage. So this is how confidence, you can see if it's more than 20%, then that's the time you start thinking whether you really want to use this model, or there's some another regression or another statistical model that you want to use it. Now going to the next kind of analysis. How does so Power BI gives you a very interactive reports as well. So you can have a it acts like an application in itself, and then you can interact with the report, you can tell something, and it will give you results back out. So I used a one simple sensitivity report. So what is the sensitivity analysis is? In finance, it is told us how your target target variables are affected with the changes in another independent variables. So what it tells you, it gives you, it is also called as what if analysis. So what if you increase this person, what if you decrease that person, what if it is uh, change in this numbers. So I'll just give an example. For example, you had a what example I have put it across. There's a seller who sells it widget at 1,000, and it has some transactions, maybe 100 transaction. What it sees for every 1,000 views on her site, it shows her it gives her almost around about 10% increase or 5% increase, just a sample. Okay, so what if she goes do and this sensitive analysis, she can always see, okay, fine, for example, if I increase the number of views on my site, it can increase my transaction, it can increase my sales. For example, if I increase it to 20%, then it increases my sales by another 10%, something like that. So these are the stuff you can do with Power BI also. I'll show you this, how this is sensitivity. If you can see the formula, it tells you a change in the dependent variable and a parameter and a state variable, that gives you the real output of the sensitivity. Okay, uh, it has okay, before I go through this, I'll show you a small demo to tell you across. Give me a second. Okay, so just take an example of a any small retail shop. Okay, so what it tells that its current profit, previous year profit was 10 million. He wants to forecast a profit to a 14 million. Okay, but in the meantime he still wants his desired profit to change. So he tells, no, 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 let's put a desired profit that changes. Get Maybe I want around about uh, so-called 20 million profit. Okay, so he wants to know what should I change in my cost price to show me that it gives me a profit of 20 million. So for example, so cost price has to decrease, then only your profit goes increases. So what it tells, if he changes his uh, cost price by 20%, he can gain 100% of his desired profit. Correct, because that's a control he can have it. And if you see the below ones, I'm these above ones are with the single parameters, the below ones are with the multiple scenarios. For example, if he changes cost price by 20%, so if you see this color coding, this color coding tells you, this is simple way of showing people that these are the green ones are the ones that can meet your targets, what are your desired profit is all about. Okay, so for example, if he needs a 40 million, just a sample. Okay, he wants to increase the profit to maybe 24 million. So only if he only does an increase, a decrease of 30% cost price, then only he can achieve it. Or he has to do a both percentages, maybe a 20% decrease in cost price but a 20% increase in selling price also can get him that target. So this is a very interactive way of Power BI using all this stuff. So going back to the slides. Okay, so people will say, what is the difference between sensitivity and scenario analysis? It's a very basic. Scenario is the one that happens in the market. Okay, scenario that has the external factors attached to it. It doesn't only have you cannot control those factors. For example, this sensitivity, you're predicting on the basis of what is there, changing the each state of the variable across different values. But scenario is kind of a market. Maybe a market is changing. For example, this COVID situation came in. It doesn't matter whether it's your so-called you won't cannot have a COVID as a under sensitivity analysis. So these are the stuff that is a difference between a sensitivity and scenarios. For If you go by the examples, what is put out there. So someone used a manufacturing, he started having a manufacturing company for certain things. So for him, he can play with cost price, selling price, so-called demand and all this stuff, but he cannot predict those scenarios tells you from a best case scenario to a worst case scenario. So that's what is the difference between sensitivity and a scenarios. Within sensitivity, you can have a different values of variables to show the end results. So that's how. But you can see even these kind of reports are very possible in Power BI. So these are called as a very interactive reports where people can play around and still get the desired result from that reports. uh, okay, now going, so these are some of the advantages as well as the approaches that someone should keep in mind while doing this. For example, sensitivity analysis requires every independent dependent variable be studied in detailed manner. But for scenario, it's more of a different scenario what you can do to win a certain particular situation. Same, if you go by fact checking, sensitivity analysis helps company determines the likelihood of the failure of a given variables. But when it comes to scenario, it more of forecasting the future events. It's trying to see what will happen in future that can impact the whole performance of the company. So for certain things, like for example, this COVID situation, no one predicted that COVID can come and impact businesses in such a big manner. So that is a scenario. Whereas reporting with sensitivity is more of a percentages increase and decrease of the stuff. Okay, let me go to the next one. Okay, so I showed you already this what kind of different studies you can work it with, the sensitivity, how the profits can up and down and all those scenarios. So 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 it can be used within finances also, where you can do budgeting and all this stuff, but that is a different use cases that you can put it across. So it's just showing the power of the Power BI, what can be done and what cannot be. Okay, now comes the real magic of Power BI. So Power BI allows lot of analytical toolings to be attached to it, like Python, like R. So you can imagine, because sometimes people say Python and R is more difficult to be in interactive reports, or more so-called, you need a lot of coding skills from a Python perspective and R perspective to get into the so-called making interactive pages and all those stuff. And the display reporting graphs are also less interactive or less attractive in a sense as compared to Power BI. So you can combine these two together to make your analytical solutions. For example, you can allow power of the Python, and it doesn't only allow Python and R, it allows machine learning. It has text analytics also embedded within the Power BI. The only thing is that you have to be on a premium membership to access this text analytics and machine learning. For Python and R, you can just be a normal user to access those things. So what does this Power BI allows you to do? Even Power, you will see very less visualization on those dashboards, but if you go, you can have a very custom visualization, and it's all free. So you can see there are multiple levels of visualization where you can define your KPIs. It's a well defined structure out there that can be used to do all these things. Now let me go back to the Power BI. Okay, give me a second. Okay. Okay, so what we did, I did a very small example of a Power BI using a prediction model for using a multilinear regression model. Okay, so what I did, I just used some sales data from a so-called companies when they put up their advertisement against YouTube, TVs, radios, and newspapers. So I use that simple data set to show how does the two things can be interacted. Okay, so you can always use, because Python and R are better tools to do data cleansing, data massaging, data so-called all those statistical model, machine learning modules that are very strong parts of Python and R that can be used. And then you can append that result set of those, or you can use those so-called data set to Power BI, and that's to complete the interactive dashboard that we can build it now. So for example, okay, give me a second. Yeah. So give me a second. Okay. Yeah. So it shows you the whole uh, machine learning model of a linear regression. So I just did a so-called I just did a test and train and do the linear regression and got those coefficients values out of it. But you can straight away use this into Power BI as well. Give me a second. Okay. So I'll just go and edit the query. Okay. So if you see this small demo, okay, what I did, I run these Python scripts. Just I'll show you the same Python script that I showed you on the Jupyter notebook. The same Python script, I ran it on my Power BI itself. So it gives me all these tables, the outputs of the Python. So I can use this now, power of Python and R, to to put a good interactive dashboard. Okay, so it's a very easy stuff. You can just transform it with you can run this Python script and you can get it across. Okay, uh, I'll share a link in the YouTube video to show how to use those Python scripts in that. Okay, uh, now coming back to my dashboard report, same thing. What I did again was with the what if analysis, what if report analysis. You can input certain values. So I'll just show you a sample data out of this. Okay, so what it tells you, a simple data on January's, what is the amount of investment you did and what was the output on the sales for particular products. So these are in millions and these are in dollars. So a certain thing like that. So what we did, I just did a okay, coming back to this. So if you know, linear regression has a simple equation of intercept plus your change in each of coefficient values with respect to the independent variables. and then you can predict the actual value, and it gives you okay. So this equation, now I'll put it as part of the of Power BI. So what I did, I read the regression model, but I use this equation in DAX. So that's how I've combined two very wonderful analytical tools together to get the output. Okay, so the same equation I showed you already. Now how I can use the same to do this regression equation, how we can use this convert this equation into the DAX. So DAX is a very powerful power query language which depicts a lot of stuff. You can do a lot, even the whole of the modeling can be done here, but that is for some time later. It would be very advanced versions. Those that's something I'll cover in, maybe I can share the link later on to show how the DAX can be used to do those. But to show just a sample where Python can be used, and I've used a very simple example. There are multiple, I think there are thousands of use cases that you can see it across in the outside world to combine these two to do a good interactive dashboard. So what it tells, so it gives you the coefficient values for each of the component, and it sums it with the input values, so you can see what is the return you will be getting across. Okay, so for example, I'll just show it in front of you. Okay, I go ahead and told, okay, I think my coefficient value with TV is the most, so I think I should invest more in TV ads to get me the more values in the predictive values. So I change this one. So I change this one. It tends to change the value of the my predicted sales. So that's how good Power BI is. So you can imagine people using this dashboards to do a lot of their business decision making, to get in onto the real on the real output of the values. Okay, uh, you can use Power BI in a lot of more other stuff, like a very interactive dashboard for loans and all those stuff in financial markets. You can have a lot of you can use R's and all those equipments together. So you can, what I showed you is what visual from a so-called data massaging and statistical model and all this. So you can always use Python for the visuals also. If you think Python visual would be more good in sense, or you don't find a visual that can suffice your requirement, you can always use Python visual also. You can integrate Python visuals also with the Power BI. So that's how the whole of the scenario works in Power BI. And there are multiple examples. I can cover only these many in short time frame. I hope you would have got certain stuff, certain knowledge, or a certain areas where you guys can work it out. So that's it from me. I think we can go towards questions and answers.
Yes, Prince, thanks a lot for your talk. I think we have time for, since we're a little bit running out of time, we have time for one question. I think the biggest one is what ING is using Power BI for, especially for data engineering, and which kind of data do you use?
Okay. So as I told you, we are doing a lot of interactive dashboards. So we do a lot of variance analysis within the within our Power BI stuff. So what we do as part of our reg reporting area, we use Power BI for toolings like someone has to do a variance analysis between months. How does the trend is happening from the balance sheet perspective? What are the lending products, or which are the clients that are very much useful, or which are the more profitable clients, which are the clients we should focus more area on. Those kinds of dashboards we can use it for from a Power BI perspective to show to the clients. And the data where it sits in as part of data engineering is that every report needs the data across. So these are the stuff where it comes where we get the data from our systems, and we integrate Power BI into our report servers, and our reports are not shared beyond. It has a lot of security protocols, so we don't use any of the cloud services. We all are on the so-called in-house services. I hope it answers the questions.
Yeah, so I hope as well for Shiman. So in the YouTube channel, we saw a lot of a lot of more questions, but because of time, we don't. Unfortunately, we don't have time for it. But if Prince is okay with it, we will share his contact details. So if you really want to get answer, you can get in contact with him. Having that said, Prince, thanks a lot for joining us from Singapore to give your talk. It was very interesting. And then I think now it's time for our second speaker. So we have Alex. Alex is a co-founder of a company called Night Analytics, and they are a software company specializing in entity resolution and knowledge graphs. She will give a talk about 3 different languages, Python, Julia, and Go. Why choose when you can have them all, or all 3 of them? So Alex is going to talk a little bit more about that, something as background information if you want to know more about her. She likes to have long walks in the countryside. She likes spicy foods, good manicures, and she recently, since Corona, she restarted playing AOE2. So hopefully that gives us her a nice introduction, and I would say, Alex, take it away and have fun with this talk.
Thanks, guys. Hopefully everyone can hear me. You can say in the chat if you can't. So my talk is maybe somewhat controversial because I think it's quite obvious that there might be some downsides to having multiple languages in your code base. But I think also with the kind of growth of microservice architecture, this might be less of an issue. So basically, my company had quite a number of requirements for picking a language to develop our product in. And there isn't really a one size fits all. So we kind of were looking at what kind of value we could get from mixing and matching, and also kind of how we can do that mixing and matching. A few caveats before I get started. Because I'm talking about languages, I know that there's a bit of an inevitable, oh, but have you tried this one? No, I probably haven't tried every language, but I'm very open and happy for advice on other languages that I should get to know. So feel free to put those in the comments. I picked these particular languages for reasons that I'll discuss in the presentation, and hopefully I'll be able to outline the kind of criteria that I have for reviewing them. So a bit more professional background about me. I originally studied mathematics and economics, and for the last 8 years or so, I've been building and deploying, you can call them advanced analytical models, machine learning models, also as a consultant. Because of that consultancy background, it means that I've been kind of put into teams with many, many different data scientists, different data engineers, loads of different data challenges and deployment challenges. I've been lucky enough to work in, well, over 15 tier 1 or global banks and insurance companies, which means, again, I've kind of met many different problems and challenges to overcome. Bit more personal stuff. So I'm originally from the UK, which you can probably hear in my voice, but I now live in Utrecht in the Netherlands. I started Night Analytics by myself 2 years ago, originally just to do some freelancing consultancy work. But I had the niggle in the back of my mind that I had a good idea that I wanted to turn into a product. So I was developing that on the side. And it was the beginning of this year that I decided to actually put the time in to launching my business as a software company. So we build entity resolution algorithms, which is essentially kind of knitting together and pulling together siloed data to give a single view of either individuals or businesses. So a bit about our needs. We often dealing with really high volume data, and we are building these distributed knowledge graphs. So there were a few core components. We needed stability, scalability, speed, and simplicity, which I think is the core for any good enterprise software. But we also needed great data science support, as AI is kind of built into multiple parts of our product. So during the presentation today, I'm going to look through the kind of strengths and weaknesses of all of the languages, and talk about why we went for a combination of Go with Julia and or Python. And then I'll show you a very high level architecture of essentially how we got them to work together. So the first criteria I was looking at is adoption and libraries. The question I was trying to answer from a business and technical point of view was, is it easy to get started? How is the support of these libraries or languages going to be? Will I be able to hire people to do these jobs? And do we think it has longevity? You can see the two graphs that I've put in. The first one is Stack Overflow trends graphs, which actually show the percentage of questions asked in each month for the given languages. And you can see that Python just far overshadows Go and Julia. I think that's to be expected from what most people know about Python. When you zoom in a little bit onto the Go and Julia lines, you see this kind of drop off from 2019. I was initially a bit surprised to see that from a Go perspective, but it looks like actually, because it's a percentage of all questions asked, the sheer growth in both JavaScript and Python mean that almost any other language has this same dip. So it's actually not as concerning as it looks. The second graph is around modules. So how many libraries are there available? And again, Python massively overshadows. So from the Go point of view, a lot of what we needed is actually available, but it's still comparatively smaller to some of the more mature programming languages. Really nice little tidbit is that Kubernetes is written in Go, so that gave me a bit more confidence that it might be sticking around. Julia definitely has far fewer packages, much smaller community, and I'm a bit concerned about the fact that it looks quite stagnant. I'm not sure that I've seen the growth that I would hope to see if it was a language that I wanted to, rely on heavily for my software product. And then Python, as we all know, is general purpose, easy to learn, easy to use, super amount of support, and the adoption is massive. I've got a second graph that was a bit tongue-in-cheek. So I found this also whilst I was putting this deck together, which was a percentage of developers who are developing with the language or technology and where they've expressed interest in continue to developing with it. You can see that Python, Go, and Julia are in the kind of top 6 of those. And then you can see a list of all the languages that have maybe given a few more headaches over the years. So the next criteria I was looking at is performance, speed, and execution. And this is where both Go and Julia really shine. So I found this nice website, which I think a lot of people are maybe familiar with, called Benchmarks Game Team. And they have a number of different programming challenges, let's say, and that they kind of race languages against each other. In almost all cases, Go and Julia perform very well. Sometimes Go beats Julia, and in some cases, Julia in fact beats Go. There was only one test on that website which Python actually beat any of those two, and that was the regex test, where they basically have to use a simple regex pattern to manipulate a data format. So what did this mean for me? So Go, the performance was super high. Typically seen in these statically typed languages. It is compiled, which some people complain about, especially during development, but it's super quick to compile, so it's almost not noticeable. For Julia, the times were exceptionally fast, especially for in the pool of languages that Julia is typically chosen from, which also includes R. You can see that the speeds are C-like, or C. That's what I guess they sell themselves are as well. I would say that what I've put here is that Julia is not just a compromise, it is like quite outstanding in its speed. But again, people have complained that the startup time can be slow. And I didn't want to completely bash Python. I think that some of these tests also have to be done with a grain of salt. There is certain things that Python does really well at, and there's been a lot more interest in Python speeding things up. So I think that there's a general consensus that for prototyping, there's not a lot better. Python is very easy to use. The lack of types mean that you don't have to check a lot of things. You don't have to be super precise, and you can still get something working. But I think it's hard to ignore how it's slow compared to other languages. Okay, scaling. So when I'm thinking about scaling, again, I'm looking at, will my program, when I'm handling massive volumes of data and running on various different machines, will it be able to handle the volume? Will it be able to meet SLAs? Can it utilize the processing power that I actually have available to me? And I've kind of put two important factors in measuring this, which is whether a language processes with threading or multiprocessing. So for Go, it's really built into the language. It specializes particularly in threading and concurrency. There's a lot of love out there for the Go routines and channels that are built into this language. It makes it very easy to, even for people who maybe haven't done threading before, because it's so intuitive. For Julia, actually, I was reading that they took a lot of their inspiration from the Go architecture as well. So you see a lot of the advantages that Go has in Julia as well. They have, well, they claim that they have 3 types of main features for this concurrent and parallel programming. And it's not seen so much in Python. So for our use case, there's a famous global interpreter lock that a lot of people talk about that some people don't care about as much. For us, it just wouldn't be applicable for a lot of our software. I read this interesting quote that all a GIL does is make sure that one thread is executing Python code at a time, which seemed a little bit counterintuitive to me. I also have read a lot about the multiprocessing that Python has to offer, and I've tried it myself. But I find it to be not very intuitive, especially when you compare it to how easy it is in Go. The kind of shining light, or the little beacon, is that because Python is so widely used, it can make use of a lot of frameworks that might be run or written actually in other languages in the back end. PySpark is a great example of that, TensorFlow also. And so I think when I was looking at scaling, Go and Julia kind of take the biscuit with this one. Okay, readability and ease of use. It's difficult for me to really say much negative about any of these languages when it comes to readability and ease of use, but there are some quirks. So Go aims to be simple and uniform. I found it particularly easy to pick up. It compiles into one single executable that runs standalone, and even packages go inside itself. It makes it really easy to deploy on Docker or Kubernetes. One of the issues that kind of haunts this language is that the generics are virtually non-existent, or are non-existent. It's been coming for maybe years now, actually. So that's definitely proven to be a challenge. The reason why you might, for people who don't or haven't used generics before, who might come from different background, is that things like a math.max function will only work on doubles. So this is a case where you can't genericize the math function for all types of numerical variables. such as integers. And that, when you extrapolate that to other bigger problems, can become really painful. From a Julia point of view, again, really easy to use. You can use it in Jupyter notebooks as well. Has nice IDE. One of the big selling points of Julia was also that it interfaces nicely with Python, R, and MATLAB. But the issues around this language is that I've heard people say, yeah, maybe it's just another spaghetti code academic language, which I found not particularly nice to hear. But I kind of, having worked in many different academic teams running and deploying and developing data science projects, I can sympathize. One of the most unfortunate things about Julia is that it indexes at 1. I don't know why they made that decision, but it's something that I still struggle to forgive them for. And Python, so nice IDs. I put readable with the question mark, and I'll come to that in the issues. But I think there's no doubt that it's super quick to get something. Now, the challenge for me is that I don't need to get something. I need to get something that I can reliably productionize relatively swiftly. And I think that's where I get the overhead of Python sometimes. When speaking to a few of my colleagues and friends about this particular part of my presentation, almost everyone had a small war story about, oh yeah, I tried to do this and then this bug came back later that if I had a typed language would have been fine. But the other thing that I heard was that there's just so many choices and so many options that it's got to the point where you join a new team and you kind of have to learn what that team likes to work with. So you might have to learn a bunch of new packages that you haven't used before. When you read someone else's code, they might have written it in a way that isn't instinctive to you, even if they've followed, maybe PEP 8 or something similar. And so the final part of that story is that if you do have to learn those new packages, if the documentation isn't as great as we would all like, then you can often end up struggling to figure out what the function is doing. This is partially because you don't necessarily know what objects it can give back, and you don't necessarily know exactly what it can take. And that's due to that dynamic typing. So this is a few small code snippets I put together in case anyone was interested or hasn't used these languages before. I just made some super simple functions that essentially select a random object from an array, although you could argue, is it a list array or a slice? In this case, I think array kind of covers them all almost. So Go looks like the most verbose in this case, but you can also see that half of those lines are just taking up with the defining the package name and the imports. But inside the function, they could all be one single line, but I think 3 is quite legible. Okay, and then onto my kind of final criteria, which was data science support. And this is where Go fails miserably at the moment. I think that there's a lot of academic debate about whether we should be building our data science models from scratch or from using a few tools. But the fact of the matter is that there's a reason that Python scikit-learn is so popular, and it's because you can try out models that you maybe haven't tried before. You can also see loads of nice examples, and it's very quick to implement stuff that you have used before. There's no real established high-level libraries in Go. And so I think that it's still early stages. I think that the generics problem that I mentioned earlier might be part of the problem here, because you can't generically define a kind of trainable model. There was a really nice response to a question about the future of machine learning in Go on Reddit that pops up on Google if you do the search, but I've added it to my presentation in case anyone's interested. And it kind of outlines a lot of the libraries and the challenges that they're facing, but also looking for support to develop more. Julia has multiple implementation of common machine learning algorithms, and it kind of is trying to adopt the scikit-learn framework. So it has a scikit-learn.jl, which is using a lot of the kind of popular Python machine learning algorithms, and either some of them are rewritten in Julia to be quicker, and some of them are just kind of calling out. I mentioned before that Julia is kind of known for interfacing well with Python and R. So if you are missing something, you can typically just add a function that you might love from a language that you know better. And Julia's been developing its own TensorFlow. It's not something I've tried, but I know that there's some good evaluations of Flux online. And finally, Python. Well, it's probably the most popular language used for most machine learning applications nowadays. It has extensive libraries, makes it a really obvious choice when you're starting a data science team or machine learning. TensorFlow, I guess, and a few other interfaces that I mentioned earlier, or frameworks, work really nicely and play with the Python very well. So the only thing that I think is worth a mention is that when you do get multiple data scientists coming from different backgrounds, you sometimes end up with both Python and R projects in the same company, and that can prove quite challenging to maintain over time. And I think that's just maybe a strategic thing that you have to deal with. So I guess this is where I round up my conclusions. The first thing to say is that all of these languages are easy to pick up and use, and that makes them a good candidate, especially for small companies, and even more so if they are young languages, because the last thing you want is to pick up Go and then have to spend many weeks learning how to write it, and I haven't found that has been the case at all. So what's Go great for? Speed, scalability, structure, ease of development. And I found that there's enough support for the software, but certainly not for data science yet, at least. Julia, I think that the biggest challenge it's facing is that it's not growing fast enough in adoption. It's really quite impressive when you look at the speeds compared to Python and R. And it does have good data science support. And then finally, Python, huge adoption, massive amount of support, and I do believe it's getting faster. So after that kind of evaluation, we decided that we wanted to use Go for our runtime software, but benefit from some of the data science capabilities available in Python and Julia. So we came up with a kind of combined solution, which is a little bit different from combined solutions that I've typically done before. And this is what it looks like. So you can see that our main software module is written in Go. That's in the blue step. You can start blue square A. During our program, we write out to disk some of the data that we've already processed. Now, what's key here is that we actually do a lot of the feature generation in Go, even if we maybe discovered some of those features offline. And what that does is it means that the data that we send over is the data that we would also be able to apply a model to. So we keep as much of that computation in this fast language. And then in the offline training and exploration, we can ingest that data, train the model, tune the model, we can explore it, we can potentially look at adding other features. But for the day-to-day running, this can run anytime, it can be any speed, and it can be written out to disk at any time. So all that happens is that the model will get replaced with a newer version, and then our runtime software can pick up that new model and actually implement it in Go. So there's this super nice library, and there's many others. We were looking particularly at like GBM and XGBoost, and this library Leaves was developed in order to be able to read models that were trained in a different language, but be able to apply them in Go. So actually our runtime is all in Go. And that's it. So I don't know if there's been any questions in the meantime, but
hi, Alex. Thank you so much. Yes, we do have a lot of questions. Thank you for your presentation, Alex Rieden. So the first question is from Cayetan, and he wants to know, are these benchmarks showing results of default Python library, or maybe they use a C-optimized libraries like NumPy, Cython, or Numba?
no, that's a good point. So I can give you a link to the benchmarks that I used, and maybe we can look a bit further. What they say is Python 3, so I don't know if they also use some of these C-optimized libraries, but that's a good point. Yeah.
Okay. The second question is from Kante Kamel, and is asking about index from 1, probably because of MATLAB.
Yeah, I think so too. I mean, that's the only obvious reason why they might have kept that. I think they also took a lot of their syntax from MATLAB. That's what I've heard. So.
And again, from him, he's wondering whether there is another Spaghetti Code Academy language. Where do you see Python in the next 5 years?
Oh, that's a tough one to say, because Python, from my point of view, I think for my use case, I'm going to be obviously trying to transfer to a different language. But when it comes to Python, has so many other use cases that I couldn't speak on them all. I don't see it going anywhere anytime soon, and you can see that its growth hasn't slowed down; it's only got faster. So.
Okay, we do have another question, and is from Fabian, how is finding documentation or certain solution on the different languages?
Yeah, so I think that that's quite well reflected in the graphs I showed about Stack Overflow. For a majority of the problems I've faced, I've definitely found at least partial solutions. I think Python, weirdly, I sometimes get challenges because there's so many old versions of Python now, and there's multiple different ways of solving the same question, that sometimes I think I get a solution quicker in Go because there's less options. Yeah.
Okay, we do have another interesting question, Alex, for you. What kind of advice would you give to a young researcher in the field of data scientists?
I think it's important to have breadth in the challenges that you try and solve. It's very easy to go down a route of like only solving regression type problems. But I think early on, it can be really valuable to try your hand at like deep learning problems that's really much easier, much more accessible now than it was, let's say, 5 or 6 years ago. Try your hand at looking at images, try your hand at classification problems. It's like that experience, that breadth of experience early on means that you can choose to kind of specialize and get depth in one of those fields later, I think. Yeah.
Thank you so much, Alex, for your amazing presentation and your time. Thank you.
No problem. Thanks, guys.
Bye. Okay, we go now to our third speaker, which is one of our South African colleague, and it's a data engineering working with us on WBA. And outside of work, yeah, he's doing great things outside the tribe. Like, for instance, he's an excellent salsa Cuba dance instructor. And before COVID, he used to give us very nice hugs, but unfortunately, due to COVID, it's all virtual now. So, and the title of his presentation is Complex Docker Builds a Journey Through Tricks and Tips and Creativity. There you go, Bongani. Good luck.
Have fun.
Hopefully everyone can hear me well. And if I can get a thumbs up. Right, okay. So I'll assume everyone can hear me well, and I'll begin presentation. Okay, So my name is Mongani, and I'm speaking to you from the ING headquarters in Amsterdam, Netherlands. If you're wondering, many of us are still working from home, but I requested for special permission here to be present here so I could avoid any possible technical difficulties. Today, I'll be presenting to you about a journey me and my colleagues went through with our complex Docker builds. My official title is a data engineer, but over what you consider what I've been doing over the past year has been more backend engineering focused. Work in wholesale banking advanced analytics, and in particular, I work with a product called the Data Analytics Platform. The Data Analytics Platform is a performance-driven big data exploration platform. So what we initially wanted was a platform for where our data scientists and BI developers could focus on their jobs and not have to worry about setting up Jupyter Lab or setting up Spark in order to do their job. What we wanted was a simple click solution where a user selects a certain set of tool sets and a container spins up with the data readily available. In particular, what I work on is work on data science in a box within the DApp platform. Uh, Data science in a box, or DS box for short, is a handy tool set to explore and analyze data and create models. Um, DS box includes a Linux environment with JupyterLab, VS Code, Python, R, Spark, and all kinds of flow, including Airflow, TensorFlow, and MLflow. DSBox in itself is completely containerized, and it runs on our powerful Kubernetes cluster. What you see to your right is a high-level architecture. So we have this lightweight API Callisto, which interacts with the DApp platform. And Callisto is in charge of creating user images. And we create those user images through GitLab. And those images will be stored in our JFrog Artifactory. Callisto is also in charge of deploying these images to our Kubernetes cluster. So at the beginning of this year, we realized that we're about to hit a wall. We're getting many new user requests for DSBox, and our code base was not the most pleasant to work with. So just to give an overview, our Docker files were about 400 lines long of Docker file steps. And for us as developers, it was difficult to understand where, if we need a change and if issues were addressed, if issues came up, where to address them. Also, our images which were produced were quite large, so they were about 5.2 gigabytes in size. This made it actually even slow to deploy and extremely slow to build the images. To give you an overview, in the best time, and one image would take about 90 plus minutes. And in the worst case, our GitLab pipeline would actually time out at the 2-hour mark. So coming up at the beginning of the year, we decided we needed to rebuild. We needed to make things better, stronger, and faster. Now, on to making things better. We decided to revisit the Docker best practices. And I won't spend too much time on this. What I will do is highlight some of the best practices we continuously do in our development process. So when you make sure you're adopting best practices, make sure the first thing you want to do is reduce your image size for faster builds, faster deployments, and it actually saves space on your registry. The first thing to do is remove any unnecessary packages or build steps. So this will be like removing development tools or debug tools which you include in. So in that case, as things which are not needed by the end user. So for example, here, Wireshark is not needed by the end user, so remove it. Another tip, which we also found out, was that if you're using a Debian-based Docker image, so and you're installing packages, make sure you include this no installs recommend. The Debian package manager actually installs recommended packages automatically, even though you didn't instruct it to. So it'll best to include that. If you're using a Red Hat package manager, you do not need to worry about that. That's handled automatically. The next thing to do is make sure, take advantage of your Docker Manager cache. Uh, so, sorry, remove any package manager cache. When you do an install, make sure you clear your package manager cache because this will end up being or will remain there through the life of your Docker image. So it's good enough to remove it there. Also notice how the pack for an execution install that we chain it together, and this is to avoid having multiple steps. What you do not with multiple Docker steps, what you want to avoid to do is doing the one below. This will have, if you do the below, you'll have multiple Docker steps, and your Docker build will actually take much longer to conclude, and you might actually hit where you installing from an outdated package manager. The next thing, take advantage of your Docker cache, and in order to speed up your Docker build. So when you want to do this, you need to realize that order is important when it comes to your Docker builds. So if you make a change to a code line, or if you to a Docker step, all the following steps in your Docker build will need to be rebuilt, and that's going to cause a Docker cache bust. So in order to avoid that, if you can identify any frequent changing, so like in this case here, you're doing code changes in this target file, it's rather best to put it at least most of the bottom. So you need to order your most frequently changing content to avoid any cache bust. Now, one thing we also did was to ensure that we parallelize our builds. So for us, our images, we initially had two sets of images. We had a Python 3.6 image and a Python 3.7 image. And within our CI/CD, we only had one job, which was executing this whole build step. And this is why evidently it took about 90 minutes, and in the worst case, 2 hours to actually complete the job. And what would actually, worst case is that if there was happened to be some issue in one of the build images, the entire job would fail. So it was only natural for us to make sure that each build was produced by its own job. So what we ended up doing was we modified our GitLab CI/CD to build multiple images at a single stage. So we have a before here, and this is how before it looked. And after we did the changes, now we're producing all the images here, and we even added a third image. So next, we needed to make Get Strong. There was a use case for us to have flexibility in our tooling. Currently, or previously, our form was for users was to have it all or have it all. Users had little choice in what actually went into the DS box. They got a DS box image with all the tool sets. What we thought would be nice is that if we give the user an ability to choose what tools they want in their DS box images. So, and also this would also be advantage for us because if a user chose less tools, it'll actually mean a quicker build, and it'll decrease our Docker registry space. Less space would be consumed in our Docker registry. So to give you a problem description here, this is what we went through when going through this. Think of user A. User A wants Jupyter with CUDA. Well, that means we'd have to take our base image, put Python, put Node, and put CUDA in it. Whereas user B wants Jupyter with Spark, well, then you will have to take the base image, put Python, put Node, put Java, put Scala, and put Spark. Whereas user C, they want VS Code with R. So then for that user, would have the base image, would need to include VS Code and R. So as you can see, there are too many combinations to cater for. And if we were to introduce a new framework, a new tool, a new language, it'll introduce more complexity. So what we needed was some form of a structured dependency solution, but for Docker builds. What we came across was Docker Make. Docker Make is an open source open source project. It's a command line tool to build and manage stacks of Docker images. So with Docker Make, you can mix and match different sets of build instructions as a dependency graph to create maintainable and extensible stacks of Docker images. So for example, here on the right, and once we adopted Docker Make, you'd create a YAML file, and you can see here we'd have the base image, and it'll be taken from this Fusion base image, and would call it dev base. And you'd have all these other images, and for Docker Make, you'll have this requires to indicate that it's based on top of this other image. And for example, here we have this final image called data science image, and it requires this Python image, airline data image, and plant data image. And when you run Docker Make, you can actually see that you get sort of this dependency graph. So here we have the data science image, and it knows that for this data science image, it requires those three above images, and those three above images require that one, dev base. And dev base is based from Fusion/base image. So once we adopted Docker Make, we actually ended up with the following dependency layouts. It's a much clearer dependency layout for us. So remember, I mentioned that our Docker, we had this one single Docker image, which was 400 plus lines long. Once we adopted Docker Make, we're able to actually modularize our Docker build steps and break them up into separate different Docker images and base them off and lay out using Docker Make to indicate which one would be based off which one. So this is what we kind of got at the end, a much clearer dependency layout, and it made it easier for us as developers to pinpoint where a change should go, or if we need to introduce something, it actually made it much more clear for us. Now the next step, we needed to go, as Jeremy Clarkson would say, faster. So to go faster, it needed to improve our Docker build speeds. Not many might know, but the Docker builder, which it comes with Docker, is quite a legacy builder. It has an outdated design, and the code base of the builder made it difficult to introduce any new features. So every time there's a new Docker release, there weren't that many innovative features. The Docker builder was tightly modeled with the Docker instructions and had a linear build design. It had suboptimal performance, and it uploads the entire context. And by that, I mean that even if you made a single change, maybe to even like the final build step, this Docker builder would upload the entire file, the entire context, even though you changed one line. So we found out that there's a new Docker builder called BuildKit. It's produced by Moby, or some people also call it Moby BuildKit. It's the new BuildKit builder, and it has new Dockerfile features and many bug fixes. It introduced concurrency building. It has lazy context uploading. So so with the build kits is that if you change one file, then one build step, then that's the only build step which would get uploaded. It has extremely better caching than previously. It protects your secrets and SSH keys. It works with and without Docker, and it's daemonless. You have the ability, if you want to containerize build kits. So if you want to, you can have a Docker within a Docker. It's also compatible with your old Docker files, so not many changes. You don't have to do any changes. And you might not know, but it's actually been available since Docker 18.09. Now, what did I mean that the legacy builder is actually is linear? Well, if you take a look at the left, when you run Docker build on your Docker file, the legacy builder actually goes from this top-down fashion. So it'll just go top to bottom and it'll run each step in this linear fashion. Versus build kit, when you run your Docker build kit actually first transverses from the bottom up. So it does a transversion and it creates a tree and it tries to identify unneeded stages or stages which can be parallelized. So what you get with Docker build is that once it runs your Docker build, it transforms it to this. So it can actually identify that it can run this in parallel and run these set of stages in parallel next to each other. So if you want to use build kit, how do you enable it? Well, it's quite simple. You can simply pass in this environment variable called docker build, docker underscore build kit1 when you're running your build, or you can set in your Docker daemon this following configuration, and you'll have Docker up and running. Now, there's some new news. This actually was announced last week. If you're using Docker desktop on your machine, feel free to update to Docker 2.3.50 because they've actually enabled build kits by default. So I'd actually suggest updating your Docker desktop as soon as finished with this presentation. Now, I'd like to also do a quick demo on build kits. So I have prepared this Docker file here. You'll see here I have these set of build stages here, these build steps, and I run a sleep command, and I have another set of build steps, and I run a sleep command, and I produce this final image based on those set of build stages. Let me exit quickly. All right, cool. Let me zoom in. Now, I'm actually going to clear my Docker system. So everything I'm running on a fresh Docker system, and I'm not taking advantage of the cache. First, what we'll do is we'll run with the legacy builder. And there we go. There's the first sleep right here. Right, and there's the second sleep going. Exciting stuff. All right, and this took about 20 seconds to complete this image. Now again, I'm going to clear my system, my Docker system, so I'm not taking advantage of the Docker cache. And now I'm going to run it using build kit. And as you can see, the first thing, you already see that Docker build kit has a new user interface. And we're already at the sleep commands, and you can see they're actually running in parallel over there. And this took about 14 seconds. So nearly half the time of the other build. So, but just by parallelizing, we just about half the time of the Docker build. Back to the slide deck. Great. So other features of Docker build. Docker build introduces context mounting. So with the previous Docker build, if you needed to actually introduce a file and work on it, you needed to copy that file over. So as here, you copy the file over, you untar it, and if you're doing your best practices, you need to make sure to release it. But then you're only releasing it on the final layer. And remember, you have all these other steps, so you're introducing more steps and more layers. Now, build kit, on the other hand, has this new single command. You just need to turn on this experimental syntax. Now, what the experimental syntax doesn't mean that it's going to go away. They're just not fully sure of the syntax. So these features are there, but in the future, they might change the wording or the naming of the syntax. So what you do introduce the syntax, and now you run the single command called a run mount, and you'll actually mount your physical hard drive or the physical machine, and you'd mount the files and you'd operate on those files within your Docker image. And so you don't have to copy anything over. You don't have to make sure that you clean your Docker build as well. Another thing here, so with the syntax mounting, so don't do what's on the left, especially if you work in a security environment, especially if you work in a bank. Do not copy over your SSH keys or secret keys. Please do not do this, because those will allow your keys to be available later on. What you can rather do is using build kit, you can rather mount using the mount syntax, and now you mount an SSH, and build kit will know that you're mounting an SSH key, and it'll make sure that that SSH key is only available within this run step, and it's not available anywhere else within your Docker image. And you just indicate that you're passing over SSH keys when you run your build, also using this keyword. So I would want to talk more about build kits, but there's a lot of features. My best advice is for you just to turn it on, see what it does for you. There are other very good features like the cache mounting, which has extremely improved. But for now, I just suggest turn it on and see what build kit does for you. Now, wrapping things up, we made things better, stronger, and faster. And where did we end up? Well, our development process has become much easier with doing our Docker builds, and we were able to make quicker releases and introduce more user features much quicker. Our time for builds images improved dramatically. So our builds went from 90 to 180 minutes down to 20 to 35 minutes. Our size of our images were also reduced drastically, and we have a better understanding of our code base. We also were able to introduce flexibility in order to add new tools in the future. So I'd like to thank everyone for listening on the talk. If you're interested in more depth and hearing about it, there's a QR code here, and feel free to scan it, and it will take you to a presentation about the data analytics platform. Below it is a QR code for build kit, and if you'd like to learn more about build kits, that will take you directly to build kit. And if you'd like to know about Docker Make, there's a QR code for Docker Make. Thank you everyone for tuning in, and I'll be taking questions.
Yeah, so thanks a lot, Bogani, for the very interesting talk. We were having a look at the chat, but we don't see any questions so far. So if you have any questions, just let them know. Yeah, maybe you want to give some last words to Bogani?
No, thank you again for your presentation. It's especially sharing the QR code so that it's easy for everyone to have access to it. And then just a small reminder that we do have a question. Sorry, we do have a question. What do you know about Docker, and then that you wish you knew when you started out?
So I'm not sure if we still have Bogani in the studio.
Already left.
I'm still here. What do I wish I knew about Docker before previously? It'll definitely about Docker caching. I think that's one of the things people should, when getting introduced to Docker, you should know about the Docker caching and how to take advantage of it, because it's one of the factors which decides how quickly your builds are. So if you can't take advantage of the Docker cache, and your builds might take much longer than ever expected. So I definitely say make sure you know about Docker caching.
All right, thank you.
Yeah, so I think we had our 3 talks. I think we have one item left from our colleague Nicoletta. She wants to share a little bit more about more the, if you're interested in ING, you want to keep up with us, we have some insights and some sharings from her left. So let's give the floor to Nicoletta.
Hi, I'm just waiting for a thumb in order to say if I'm live. Thumb? Yes, all good. So congratulations for this amazing meetup. Once again, the organization was perfect. So we would like to extend this nice experience you just had with after event online content. So I will say a couple of words on that. My team, Wholesale Banking Advanced Analytics, is a multicultural, diverse, and inclusive ING tribe. We create algorithmic data-driven products for our clients. We love experimentation and care about diversity and inclusion. Our Medium blog mirrors who we are, with a nice mix of business and tech content, including a wealth of nice engineering blogs, so make sure to check it out. And since we can't stop sharing knowledge with the tech community, make sure to also check our ING Medium Tech blog with top-notch engineering and data science content from our tech colleagues across the organization. ING wants to make it happen with top talent, and some of our analytics teams, including WBA, are growing, looking for new colleagues. So if you're interested in joining us, check our career path, where you can find positions such as machine learning engineer, data scientist, NLP engineer, and more. We will now share all links here at our chat and at the after event email you will receive. Again, many thanks for attending, and many thanks, congratulations for the amazing organization. That's it from me.
Yeah.
Thanks, Nicole.
Yeah, so I think one last shout out to our speakers, Prince, Alex, and Bogani, for your amazing talks. Because I think all the questions and comments on the chat, I think people really liked it. Yes. We want to thank you, Nicoletta. Thanks a lot for sharing these last links and where people can find a little bit more information about ING, the WBAA team, and about what's happening in the analytics field and IT field at ING. Thank you, of course, Samantha, for hosting this with me. And I think on the background, literally on the background, we want to thank Anna as well for doing all the nice thumbs up from her for all the coordination on the background. Yeah, we really hope you liked it.
Hope you like it, and make sure to join us again for the next one, 8 October Data Science Meetup, and then on November
12th.
Yes.
We have the next edition of the Data Engineering Meetup. Please check out meetup.com and Eventbrite to see your future events and sign up, and hope to see you then.
Thank you. That's all for us.
Yeah. Enjoy the rest of the week.
Bye.
Bye.